children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. From where are we to continue, children? This is NCERT, the second exercise, exercise 7.2. So till where have we finished? Yeah, please look into your book. Have we finished example 5?
Yes, ma'am. Yes, ma'am.
Both the methods, Madhumita?
Yes, ma'am. Ma'am, actually, you sent the screenshots of, last class you showed us some screenshots and told us to write it down, ma'am.
Okay, but I have not explained, right?
I'm not sure, ma'am.
Okay.
Yes, ma'am, you wouldn't explain, but you completed example 5.
Oh, we finished example 5, is it?
Yes, ma'am, both the methods.
Okay, so we have to continue from example 6. All right, Danya, thank you so much. Okay, so here, example 6, in an isosceles triangle ABC, so you can see it here, in an isosceles triangle ABC with AB is equal to AC. See, I've shown the triangle separately here. Can you see it here? In an isosceles triangle ABC, see this triangle here? So in the isosceles triangle ABC, we have other line segments AD and AE also. See, we have these line segments AD and AE also. But see the triangle ABC alone here. See the triangle ABC alone here. Isosceles triangle ABC with AB equal to AC, with AB equal to AC. So this is just for us to understand, okay? So these, you can just call them rough work, rough work. All right, so here you can see the isosceles triangle ABC with AB is equal to AC. And we know that in a triangle, when two sides are equal, the angles opposite to them are also equal. In a triangle, when two sides are equal, then the angles opposite to these sides are also equal. So it is given that this side is equal to this side. I've told you one thing. These two sides, they meet here. See, these two sides, they meet here. So leave this angle, ignore this angle. This angle is equal to this angle. The equal sides, they meet here. The equal sides meet here. Okay, leave that angle. The remaining two angles will be equal. The remaining two angles will be equal. Or going by the statement, the angle opposite to this side is this angle. The angle opposite to this side is this angle. Opposite. The angle opposite to this side, the angle opposite to that side is angle C. Or you can also remember like this, the side is AB, right? The side is AB. So which is that remaining letter C? So angle C is the opposite angle. AB, the side is AB. So that remaining letter or the remaining vertex, triangle ABC. So AB, which is that other letter C. So angle C. The angle opposite to AB is angle C. And similarly, the other side is AC. ABC. AC is the other side. So angle B, that letter which is missing, ABC. AC is the side. So B, angle B is the angle opposite to the side AC. So opposite to AB is angle C, opposite to AC is angle B. And since it's given that AB is equal to AC, angle B is equal to angle C, or angle 1 is equal to angle 2. Okay. So in an isosceles triangle ABC with AB is equal to AC, D and E are points on BC. So D and E are points on BC, such that BE is equal to CD. BE, see here, BE is equal to CD, BE is equal to CD. D and E are points on BC such that BE is equal to CD. That is the length of the line segment BE is equal to the length of the line segment CD. So given all this, we'll have to show that AD is equal to AE. We need to show that AD is equal to AE. AD is equal to AE. Okay. So now going by this proof, let's understand this proof first. So going by this proof, you will have to take up a triangle that has AD as a side and another triangle that has AE as a side. And you should select the triangle so that you can, use the information given. So in this side AD is in triangle ADC. See ADC, this triangle ADC. See, you cannot choose one small triangle and one large triangle and try to say that they are congruent. See, like you cannot take this triangle and the whole triangle. You will have to take, so that you should, you should have that intuition that you have to take these triangles. So triangle, the triangle, I'm sorry. Yeah. So triangle ADC, see here this triangle ADC has a side AD. That is why we take this triangle. And the triangle AE, see here this one, AEB, this triangle has a side AE, So we are taking up triangle ADC. You can see it here, ADC, which has AD, and the other triangle is ABE, which has AE, So see, we are sensibly selecting the triangles. When you take, see, you're taking this triangle and this extra thing, like that, So you're taking two triangles. See here, you're taking this triangle 1 and 2 as ADC here. So then it should be congruent to, you should take this and this one. You cannot take this triangle alone. You can't take this triangle alone. So here you have to take this triangle, which has this triangle and this triangle. So first we've taken up triangle 1 and 2 together. First in triangle ADC, we have triangle 1 and 2 together. We have triangle 1 and 2 together. In triangle ABE, in AB, we have 1 and 3 together. See, this triangle ADC is 1 and 2 together. ADC. Triangle 1 and triangle 2 together is ADC. Triangle 1 and triangle 3 together is ABE. Now, why do we take up these two triangles? Because this triangle has AD and this triangle has AE. So we are going to show that these two triangles are congruent to each other. And once they are congruent, their corresponding sides will be equal and their corresponding angles also will be equal. So when you have to show that two sides are equal or two angles are equal, you will have to select two triangles. One triangle which has that first side or first angle and another triangle which has that second side or that second angle. Show that they are congruent and hence you will be able to show that the two sides or the two angles are equal. So here we have taken up this triangle which is AD and this triangle which has AE. Now let's prove that they are congruent. So first I've marked off the information given. All right, I've marked off the information given. What are we given? We are given that BE is equal to CD. See here, BE is equal to CD. So I've marked here BE is equal to CD. I've marked that. Okay, and then we are also given that AB is equal to AC. So I've marked that AB is equal to AC. AC and AB, these two sides are equal. And now come to this figure, children. Look at this figure. Now in triangle ABC, we know that AB is equal to AC. In triangle ABC, we know that AB is equal to AC. And by the theorem, we said when two sides are equal, the angles opposite to them are also equal. So that way we have angle 1 is equal to angle 2. Angle 1 is equal to angle 2. See here. I've marked it here for you. In the whole figure, I've marked it. See here, in the whole figure, I've marked 1 and 2. And I've shown it separately also for you. This is just, these two figures are just for us to understand. See here are angle 1 and 2. Angle 1 and 2. I'll have to tell you one more thing. I'll tell you, just listen to me. So this is angle 1 and this is angle 2. Okay. And mark that here. So which is angle, this is angle 2. It's here, angle 2. And this is angle 1. It's here, angle 1 is here. So see, what have we done? Nothing. We have just used all the information given. Nothing we found on our own, except for, we found that angle 1 is equal to angle 2. Now, one more thing which I have to clarify is, now how do we use this? Now, when we have this information, AB is equal to AC, you must take the triangle alone. You must not see any other line segment that goes in the middle. When they say in triangle ABC, AB is equal to AC. Now, when two sides are equal, you want to use that property. What property? When two sides are equal, the angles opposite to them are also equal. You want to use that property. To use that property, you must take the triangle alone, meaning there should be no other line segments, inside the triangle. Then you cannot make out the angle opposite to that, the sides given. The angles opposite to the sides given. Take only the triangle and use the property. That is why I've done this here. So that's why, see, I've taken in triangle. See what is given in triangle ABC, AB is equal to AC. So see here, I've taken only the triangle, meaning not without these line segments. Without these line segments, I've taken only the triangle ABC and AB is equal to AC. Now only you can make out which angle is opposite to AB. If you see it along with the, if you see AB is equal to AC in this triangle, AB is equal to AC, then you will say the angle opposite to this side is this angle. No, you have to apply the property inside the triangle ABC. So if you see it in this figure, then you will say the angle opposite to this side is this angle and the angle opposite to this side is this angle. No, it's not like that. You shouldn't consider multiple triangles. So that way you're taking this triangle and this triangle here. You cannot take multiple triangles. You should take only the triangle ABC. You should take only that one triangle ABC, which you see here. In this triangle, this side is equal to this side. That means this angle is equal to this angle. And where are these angles in the whole figure, in the main figure? In the main figure, where are these angles? B and C here. B and C are here. And where is B in this figure? See here, B, angle 1. And where is C in this figure? Here, 2. So children, angle 1 is equal to angle 2. We get using this property or the theorem that angles opposite to equal sides are equal. And the rest is given in the question. AC is equal to AB is given. This one, CD is equal to BE is also given. So clearly it is the SAS congruence criterion. All right, or SAS congruence rule, whatever. So just now you just have to list the equalities. You know the equalities. So mention the names of the two triangles. In triangle, this is the procedure. In triangle ACD or ADC. You can name it however you want. Okay, in these two triangles. So what should you write? AC is equal to AB given. Then I've explained in this triangle ABC. See here, I've used this figure and explained that. In this triangle ABC, since AB is equal to AC, angle 2 is equal. See, angle 2 is equal to angle 1. Angles opposite to equal sides are equal. So angle 2 of this triangle is equal to angle 1. See, actually it's here. This angle 2 is equal to angle 1. But 2 is in this triangle here and 1 is here. So 2 is equal to 1. Angle 2 is equal to angle 1. So that's the other information. And CD is equal to BE. That's also given to us. So by SAS rule, the two triangles are congruent. Now you know how to name the triangles. If you say ACD, now AC goes with what here? AB. So you should say ABE. ACD, ABE. SAS congruence rule. So CP, CTC, you have AD is equal to AE. You have to prove that AD is equal to AE, CP, CT. The other proof is taking up these two small triangles, this one and this one, taking these two triangles. So when you take these two, this triangle and this triangle, in triangle ABD, see it here, ABD and AEC, these two small triangles, here and here. You know that, or you can see that ABD has AD and ACE has AE. We have to prove that AD is equal to AE, and we have those sides in these two triangles. So now let's again mark whatever was given to us. So again, in this triangle, we have angle 1, and in this triangle, we have angle 2. So you can see that here I've just presented the two triangles which we have taken up, ABD and ACE, with angle 1 equal to angle 2. And it's given that AB is equal to AC. So AB here is equal to AC here. Now we want one more information. Okay, the other thing which is given BE is equal to CD is not applicable because you can't see BE and CD here. You cannot see the side BE and CD in these two triangles. So though we have an information, we cannot apply it to the two triangles. Am I audible, children? Are you all following?
Yes, ma'am.
All right, children.
Yes.
Very good. All right, children. So since though we have another information, BE is equal to CD, B is equal to CD, you cannot see that side. See, where is you cannot find the side BE and CD in the two triangles. There is B here and E here. There is C here and D here in the other triangle. So that information, though we have, we cannot use it direct. We cannot mark like those two sides are equal here. Okay, so we want one more information. We want one more information. Now see here, children. See here. Now we know that BE, listen to this. We know that BE is equal to CD. Okay, BE is equal to CD. Now you can write it in two different ways. See, BE is equal to CD. Now, what is BE, children? I've done something else. I'll tell you both now again. So we have BE is equal to CD. Can I write BE as BD plus DE? BD plus D. Can I write it like this? Can I write BE as BD plus DE?
No, ma'am. Yes, ma'am.
Yes, ma'am.
Yeah. And then how can I write CD? How can I write CD?
CE plus
B.
C plus CD, ma'am.
C plus
CD, ma'am.
DE. 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 Now, what do you see? On both the sides, DE. So they get cancelled. Because if this DE goes to the other side, it will become minus DE. If you take one DE to the other side, it will become minus DE. So they'll get cancelled. So these two gets cancelled. So what do you get? BD is equal to CE. See, like this you can get. You can get it like this. BD is equal to CE, like this you can get. I've done something. I think you can follow this only. And for those who can follow this is also fine. So we have BE is equal to CD. I'm subtracting DE from both the sides. So from BE, what is BE made up of? BE is made up of BD and DE. If you subtract DE, that means you'll be left with BD. That's what I've written here. I've taken up this equality. BE is equal to CD. BE is equal to CD. But I haven't explained these two. I'm just telling you this. So we have BE is equal to CD. Now what I'm doing is I'm subtracting DE from both the sides. Now what is BE made up of? BE, BD and DE. If you take away the DE, you will be left with BD. So that's what is BD here. And what is CD made up of? CD made up of CE and DE. So if you take away DE, you will be left with CE. So I'm subtracting DE from both the sides. BE is equal to CD given. I'm subtracting DE from both the sides because that's a line segment common to both BE and CD. So I'm subtracting the line segment DE from both the sides. So from this line segment BE, if you cut off DE, subtracting is you're cutting off. Subtracting is you're taking away. From this line segment BE, if you cut off DE, you will be left with BD. And from this line segment CD, if you cut off DE, you will be left with CE. See, you can present it like this. You can subtract DE on both sides. Or if this you can understand, you just think about it, you can understand. Otherwise, you can use this one, this one. You can use this one. So like that, we get BD is equal to CE. So see here, BD is equal to CE. So again, it is one pair of equal sides, another pair of equal sides. And are the angles included angles, children? They are, because see angle 1 contain, and the arms of angle 1 are AB and BD. The arms of angle 1 are AB and BD. The arms of angle 2 are AC and CE. And that's what we have mentioned. See here, we have mentioned about AB, BD and angle 1 and angle 1. AB, BD and angle 1. And in the other triangle, we mentioned about angle 2. And its arms AC and CE, angle 2. So clearly by SAS congruence rule, the two triangles are congruent to each other. So CPCT, you have AD is equal to A. So I'm saying instead of this 3 children, instead of this 3, tell me what I told you. Instead of this 3, you can also write what, children? We have BE is equal to CD. What should you do? It's a class of white. Yes, children, please tell me. How can you write BE?
BD plus DE, ma'am.
BE plus BD plus DE. Very good.
Equals
And
CE plus DE.
DE plus EC or CE, whatever. Okay. So D on both the sides gets cancelled. So we get BD is equal to CE. BD is equal to CE. Okay. So children, I just want to make this announcement that in future, children who do not submit the homework will not get the link for the class. And I'll be very reasonable. I know on weekdays, I will not give you so much of homework. Because, you know, I think congruent triangles and quadrilaterals, all these are proofs. Yeah, and it is time consuming to write during the class. So in the time you will write, I can teach you 2 other proofs. So we can save time like that. So I will be giving you the proofs too. You will be writing out the proofs at home. We'll understand them in the class. And don't mistake me. So you will have sufficient time to do the homework. Children who do not submit the homework, you might have done it, but if you don't share the pictures with me, I'll not share the link with you for the next class. Of course, the meeting will be available. You will get the meeting recording. That's a different thing. But I'll not be sharing the meeting link with you. So make sure that all of you complete the homework on time and share the pictures with me. Don't blindly copy, follow whatever is given to you. If I have not explained, maybe you just have to write it. If I've explained it, then you have to understand and then write it. We'll see, whatever the case may be. Now, how many of you feel I'm very rude? Please raise your hand. It's okay. I want to know because, you know, I need to understand how I'm being with the students. If you feel I'm very rude, I cannot be like that, you know. If we don't submit the homework, you know, it's not fair for you to not share the link with us. You can be very honest, very, very honest. This is not school where the teacher is going to have grudge on that student who says that I love you even more for being honest. So do not, yeah, Arjun. Okay, Arjun says it's not fair. Okay, Arjun, in case you do not submit the homework, what do I do, Arjun? I should give you more time. Yeah.
Ma'am, I'm not having time to do the homework given in the school itself, ma'am.
Okay. So for you, additional homework from tuition, you will not have time to do is what you're saying, right?
Yes, ma'am. But I will try hard to do it, ma'am.
Very good. In that case, can you just ask your parents to, you know, like send a voice note, because text anybody can text. Right?
Yes,
Texting anybody can text. Even you can text like your parent, and meaning not Arjun. Anybody can text like a parent and send a message to me. So in case Arjun, you don't finish the homework, ask your mom or dad to send a voice note. I don't want the reason. Just a voice note that Arjun was not able to complete the homework. That's it.
Yes,
Or maybe if the reason can be given to me due to whatever, I'll be happy.
Yes,
In that case, I'll share the recording. Yeah. I'm sorry, the meeting link. Now am I fair?
Yes, ma'am.
Okay, thank you. Yeah, the others. You will try hard to finish it, huh? Class. Krishmika, Shri, Tanishka, Srijana, Netra, Madhumita, Raja, Sindhu, Sanjay.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, children. Okay, so yeah, try your best to finish it. That's important. Try your best to finish it. Every time, see, again, parents, you know, when you force them to send a voice note, they may do it also. All right, so please finish it. Don't, you know, like ignore your responsibility and force your parents to do something for you. So you finish your work And when I give you the time, when I tell you that you have to submit the work on a particular day, you judge it in the class itself that the time is sufficient or not sufficient for you, and I'll give you an alternate day. So instead of not completing, we can talk in the class itself if the time duration is not sufficient for you. All right, let's get back. Yeah, go through this and ask me if you have any questions. Just a minute, children, I'm coming back. Any questions, children? So in the other method, in the two triangles, this information is given, AB is equal to AC is given, and then angle 1 is equal to angle 2. We already understood. And then using this method by subtracting or by this method which I've shown here, you can show that BD is equal to CE. BD of this triangle is equal to CE of this triangle. So SAS rule, the two triangles are congruent. CPCTC, AD is equal to AE. AD is equal to AE.
It's clear, ma'am.
Okay, very good. Yeah, children. So this is the exercise. Exercise 7.2. In an isosceles triangle ABC, in an isosceles triangle ABC, with AB equal to AC, the bisectors of angle B and C. So this is angle B. Angle B is bisected. Okay. This is angle C. Angle C is bisected. It's bisected. The bisectors of angle B and angle C intersect at O. They meet at O. Join, can you see that? In an isosceles triangle ABC, with AB equal to AC, the bisectors of angle B and angle C. So angle B, bisector. Angle C, bisector. The bisectors, they meet at O. Join A to O. Join A to O. Show that OB is equal to OC. See this one, this OB is equal to OC. Now, OB and OC are the sides of triangle OBC. OB and OC are the sides of triangle OBC. OB and OC are the sides of triangle OBC. So if you want to prove that two sides of a triangle are equal, if you prove that, see, let me mark this angle. See, in a triangle, look at the triangle OBC alone. Triangle OBC alone. Okay, if you prove that this angle is equal to this angle, if you prove that this angle is equal to this angle, the side opposite of this angle, angle C, the side opposite to angle C is OB. The side opposite to angle B is OC. The side opposite to angle C is OB. And the side opposite to angle B is OC. See, if it is angle C, leave that letter C. OB is the triangle is OBC. Angle C, leave that. So OB is the opposite side. OB is the opposite side. Angle B, in triangle OBC, angle B. So OC is the opposite side. OC is the opposite side. So triangle OBC, if you prove that this angle is equal to this angle, then by the theorem, in a triangle, when two angles are equal, in one triangle, in the same triangle, when two angles are equal, the sides opposite to them are also equal. So if you prove that this angle is equal to this angle, then using the theorem, you can say that this side is equal to this side. So like that, you can prove that OB is equal to OC. Like that, you can prove that OB is equal to OC. So now, in the whole triangle ABC, see here, in the whole triangle ABC, we know that AB is equal to AC. So by the theorem, angle C is equal to angle B. Angle C is equal to angle B. So let's start from there. Let's start from there. Angle B is equal to angle C. Why? Because AB is equal to AC. So when two sides are equal, the angles opposite to them are also equal. So angle B is equal to angle C. Opposite to this side is this angle. Opposite to this side is this angle. So angle B is equal to angle C. Now, when two things are equal, their halves are also equal. When two things are equal, their halves are also equal. So half of angle B will be equal to half of angle C. Now, when can you use this? Only when the angle is bisected, not always. Only when the angle is bisected, you know, the two equal halves of that angle. If the angle is not bisected, then you cannot, there is no point using half of angle B is equal to half of angle C. Because you don't know what is or which is half of angle B and which is half of angle C. Only when the angles are bisected. Here, angle B and angle C, they are bisected. So you know the two halves of angle B and angle C. So we can use this. Half of angle B is equal to half of angle C. So you know that this one and this one, these are the two halves of angle BC, this angle and this angle. They're the two halves of angle B. And this angle and this angle are the two halves of angle C. See, this is one half of angle B. This is the other half of angle B. This is one half of angle C. This is the other half of angle C. So half of angle B is equal to half of angle C. So let me take this half. Okay, supposing I say, I'll just say like 1 for you now. Okay, let me take this half, 2. So what is half of angle B? Angle 1. What is half of angle C? Angle 2. So we get angle 1 is equal to angle 2. Angle 1 is equal to angle 2. See, you can take any half, but now because we'll have to show OB is equal to OC, we have to take this half. Angle 1 is equal to angle 2. That's a new result we have got. 1 is equal to 2. It's a new result. Now, where are angles 1 and 2? In triangle, see, in triangle OBC, angle 1 and 2. They're in triangle OBC. So in triangle OBC, you have proved that angle 1 is equal to angle 2. So when two angles are equal, the sides opposite to them are also equal. So the side opposite to angle 1 is OC and the side opposite to angle 2 is OB. Therefore, OB is equal to OC. OC is equal to OB or OB is equal to OC. So that's how you prove the first part. That's how you prove the first part. OB is equal to OC. Now you'll have to prove that AO bisects angle A. AO bisects angle A. This is AO. It bisects angle A. That means you should prove that this angle is equal to this angle. You must prove that angle 3 is equal to angle 4. You must prove that angle A is bisected. You must prove that angle A is bisected. Who bisects angle A? AO bisects angle A. How do you prove? You can't use a protractor and measure. How do you show that? By working, how will you say that, angle A is bisected? You'll have to show that angle 3 is equal to angle 4. So angle 3 is in triangle AOB. Angle 4 is in triangle AOC. Angle 3 is in triangle AOB. And angle 4 is in triangle AOC. Now, how will we show that these two triangles are congruent to each other? So we already know that this side is equal to this side in the two triangles. This angle is equal to this angle because half of angle B and C. So this angle is equal to this angle. Because B is equal to C, so half of B is equal to half of angle C. So this angle is equal to this angle. And AO is the common side. AO is the common side. AO is the common side. So what's the congruence rule, children? What is the congruence rule?
Ma'am, triangle AOB is congruent to triangle AOC.
What is the congruence rule? Rule.
S A SAS.
We said AB is equal to AC. This angle B is equal to angle C.
SAS, ma'am.
Are AB and AO the arms of angle B?
ASS congruence criterion, ma'am.
A?
SS.
Yes. Ma'am.
Yeah.
Ma'am, we can use SAS congruence rule, ma'am.
How?
Ma'am, it's given AB is equals to AC and ABO and
No.
ABO is equals-
1 minute. No. I'm not expecting that answer. I am expecting what is the congruence rule here?
Triple S, ma'am.
No, children, if I write these three, see, with what we understand is to show the two triangles are congruent, we'll have to write three equalities that suit a particular congruence criterion, correct? Now, if I write these three, what is the congruence rule I'm asking you? These three information will satisfy which congruence rule is my question.
ASS.
ASS is not a valid congruence rule. ASS is not a valid congruence rule. Yes, fast children.
There's no such congruence.
SAS, ma'am.
Yeah, you cannot, if you list these three equalities, there is no congruence rule that will satisfy this because it is not SAS also. It is not two sides and included angle. It is one side and angle in some other side. It's not SAS. ASS is not a valid congruence rule. ASS or SSA is not a valid congruence rule. So if we list these three information, it does not satisfy any congruence rule because it is two sides and some other angle. It can be two angles and some other side, AAS. It can be two angles and some other side, AAS. But it cannot be, two sides and some other angle. If it is two sides, it has to be the included angle. If it is two sides, it has to be the included angle. If it is two angles, it can be the included side or some other side also. If it is two angles, it can be the included side or some other side. But when it is two sides, it has to be the included angle. It cannot be two sides and some other angle. That's not a valid congruence rule, which means you cannot write which information here. What should be replaced by what? Which information should be replaced with which information? Yes, somebody wanted to say that. Sanjay, I think.
Ma'am,
Yeah.
angle can be replaced with side, ma'am. Side OB, OC.
Okay, he's telling the angle B and angle C can be replaced with OB is equal to OC, and that will make what congruence rule?
SSS congruence rule, ma'am.
SSS. What else? What is the other way? Which information can be replaced? Correct. Okay, Sanjay is right. Sanjay says take away the angle. You said angle B is equal to angle C. So remove that information and write OB is equal to OC. That will make SSS. Correct. Then,
SAS, ma'am.
yeah. So which information should be replaced with which information?
Ma'am, we can
Class, use the emoji. Raise your hand. Madhumita, Raja, Netra, Krishmika, Tanishka, Sindhu, Sanjay, Srijana. Srijana, are you there? Okay, fine. All right. Yes, what's the other way, children? We can take away
A, ma'am.
more clearly. A meaning
Ma'am, angle AB is equal to AC.
angle AB
Angle
is
ABO is equals to ACO, ma'am.
1 minute, 1 minute. Let me do one thing. Let me
Ma'am,
draw the
angle A is common in both the triangles, ma'am.
No, this is no. It's not the same angle. It's different angle in the two triangles. 1 minute, children. We prove now these two sides are equal. Now, AOB, AOC. Yeah, tell me, children. AB is equal to AC, correct? AB is equal to AC. Then this angle is equal to this angle. Because half angle B is equal to angle C, half of angle B is equal to half of angle C. So this angle is equal to this angle. Let me call it 5 and 6. Angle 5 is equal to angle 6. And I wrote AO is equal to AO. Sanjay said, take away this. You write, no, not this, sorry. Yeah, so Sanjay said, you don't write this. You write, what did he say? OB is equal to OC, correct, Sanjay?
Yes, ma'am.
Yeah, he said, write OB is equal to OC, so it makes SSS. Now my question is, I have written this, right? I have written this. This is wrong. Actually, wrong meaning it doesn't satisfy any congruence rule. This information doesn't satisfy any congruence rule. SSA is not a valid congruence rule. Now my question is, what else can be done? So Sanjay is right.
Ma'am, AO should be represented with BO equals to OC, ma'am.
Correct. You can remove this and write BO is equal to OC. Correct. You can remove this and write BO is equal to OC. Or BO is equal to CO, whatever. Because yeah, we proved, no, see, we proved OB is equal to OC. So you can take away this information and write OB is equal to OC. OB is equal to OC. Now see, for angle phi, AB and BO are the arms. And for angle 6, AC and OC, they are the arms. So clearly it will be SAS. SAS. So you can prove here using SSS or SAS, depending on what information you write. But sometimes when we have more information, we'll just write some 3 equalities that don't satisfy any congruence rule, like what I showed you first. So some 3 equalities. But then what happens, since we have listed it, we'll just make it like, okay, SSA, okay, by SSS rule, the triangle congruence. No, this is not a valid congruence rule. That's what it is. So when you have more information, be careful. Now, if you understand, say yes, you understood, children.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And some of you who did not follow, I'd asked you to watch the recordings. Did you all do that? See, take it from me. It's a very, very simple chapter. And the recordings are also available. Watch the recordings and Yeah, it's all about remembering whatever is explained in the recordings. Simply watching and forgetting is not of any use. So you should remember whatever is explained there. It's a very simple chapter because everything is given in the question. All information will be given to you. Or you'll have to use some simple, theorems like this. Sides opposite to equal, angles are equal, something like that, some simple thing. Nothing complicated. Everything is given and you have the congruence rules. So you just have to match the information in the congruence rule. That's all. So children, you said you have already written all this, right, in your book?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so here I've used SSS. Here I've used SSS. But you can also use, I've used SSS here. As we discussed, you can also, like you can mark this as angle 5 and this one as angle 6. You can mark angle 5 because, see children, you know angle B is equal to angle C. So half of angle B is equal to half of angle C. Half of angle B is angle 5 and half of angle C is angle 6. So angle 5 is equal to angle 6. And then this one, this OB is equal, this is O. So OB is equal to OC. Okay, let me write that alternate proof so that if you want, you can. Those who want it can make a note of it. Alternate proof. So in triangle, the same to triangle AOB and AOC, you can write AB. AB is equal to AC. Then angle B is equal to angle C. So half of angle B is equal to half of angle C. Let's mark it 5 and 6. So angle 5 is equal to angle 6. This is one thing. This is the second one. And the third one is BO is equal to CO. BO is equal to CO. And this will make SAS rule. This will make SAS. Two sides included angle. Done, children?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Wait, huh? Should I wait? Okay. So here, AD is in triangle ABC, AD is the perpendicular bisector of BC. So sometimes we are not sure about the meaning of, this phrase. Perpendicular bisector of BC, not an angle. AD, this line segment, is the perpendicular bisector of this line segment. A line segment is bisected, an angle is not bisected. A line segment is bisected. There's a difference between an angle being bisected and a line segment being bisected. If an angle is bisected, it is divided into two equal angles. So if a line segment is bisected, so here BC is bisected at D, that means BD is equal to CD. BD is equal to CD. AD is the perpendicular bisector of BC. Perpendicular bisector of BC. That means AD is perpendicular to BC and AD there are two things there. Read it like this. AD is perpendicular to BC. AD is perpendicular to BC. That means AD is perpendicular 90 degrees to BC. Then the other thing is AD is the bisector of BC. AD is the bisector of BC. AD bisects BC at D. That means D is the midpoint of BC. AD bisects BC. That means it divides BC into two equal halves. This one, BD is equal to DC or CD. So from this, we have two things. One is BD is equal to DC. The other one is this is 90 degrees. This is also 90. Show the triangle ABC. Show the triangle ABC is an isosceles triangle with AB equal to AC. Show the triangle ABC is an isosceles triangle with AB is equal to AC. So you need to show that these two sides are equal. You need to show that these two sides are equal. Very simple proof. Tanishka, tell me. Tanishka, how will you prove that AB is equal to AC?
By CPCT.
Yeah. No, tell me the proof fully. Which are the triangles you will consider in triangle?
Triangle ABD and ADC.
And ADC, yeah. Tell me.
AD is equal to AD, which is common, ma'am.
Okay.
Since AD is a perpendicular bisector, BD is equal to DC, ma'am.
BD of which triangle?
Triangle ABD, ma'am.
Is equal to?
DC, ma'am.
BD is equal to DC or BC?
DC, ma'am.
You're saying this one? Are you saying this? Are you saying this or are you saying this? I don't know. It's not clear. 1 or 2? You're telling me 1 or 2?
2, ma'am.
BD is equal to DC, you're saying. Okay, correct. Then?
D is midpoint, ma'am. BD is equal to DC, ma'am. And
Yeah, that you already said.
yes, ma'am.
One more thing.
Angle 1 is equal to angle 2, ma'am, which is 90 degrees.
Which is angle 1? Which is angle 2?
ABD, there is an angle D, which is angle 1, ma'am.
Name the angle. Angle A.
ABD, ma'am. There is in perpendicular
ABD.
bisector.
This one is angle 1, na?
No, ma'am. Opposite to that.
Oh, but you said ABD. ABD means this one only.
Sorry, ma'am. ADB. ADB.
ADB. Are you saying this one?
No, ma'am.
No.
That 90-degree angle, ma'am.
Okay. You're saying this one. This is 1. Okay.
Yes, ma'am. Opposite that angle 2, ma'am.
Name the angle. Name it. Angle.
Angle 2, ma'am.
Use 3 letters and name the angle.
ADC, ma'am.
ADC. Okay. ADC. This is 2. Okay.
Which is angle 1 is equal to angle 2, which is 90 degree, ma'am.
Okay. So what's the rule? Which are the arms of angle 1?
BD and AD, ma'am.
BD and AD. And that's what we've mentioned. BD and AD. Which are the arms of angle 2?
AD and DC, ma'am.
AD and DC. So what is the rule?
By SAS, ma'am.
SAS. Side angle side. So because it is this angle and the included sides. This side, this angle and this side. 2 sides include angle. In the other triangle, it is 2 sides again and the included angle, 90. So SAS rule, the 2 triangles are congruent. CPCTC, AB is equal to AC. Correct. Honestly, tell me how many of you have completed writing this in your book? No, your school classwork you have already written, your teachers taught you. I'm asking in the tuition notebook. So Sindhu Sanjay has completed.
Ma'am.
Krishna. Yeah.
Ma'am, I have just some incomplete, ma'am. Like 3 to 4, 3 questions only left, ma'am.
Okay, when will you finish it, Netra?
Ma'am, I will finish it by today, ma'am.
Okay. Sanjay, Sindhu, Krishmika, Madhumita, Tanishka, and Arjun have finished. Srijana.
Ma'am, I have only one question left, ma'am.
Okay. Danya, you were not in the meeting, no, for some time. Why? Danya.
Actually, my network connection was unstable and had a lot of problems, ma'am. Now one day I just joined with mobile hotspot. Sorry, ma'am.
All right. The others, please complete your work. Raja. Raja, you're busy with other activities like archery, whatever. Please make me also happy.
Sure, ma'am.
What is your status, Raja?
Ma'am, I need to complete, ma'am. I'll complete and I'll let.
When you do your work, then and there, it's like you're practicing. But when things are accumulated and then you have to submit it, it becomes a punishment kind of, because how much can we focus? If you have to complete some 15 to 15 proofs, it's difficult to focus. So maybe some 5, 6 you will focus and then you'll just copy it and submit it. Not in general. Please try to do your work on time in future, Raja.
Yes, ma'am. Sure.
All right, children, next one. So since we proved that AB is equal to AC, now see the triangle ABC alone. Don't see that line in the middle. See the triangle ABC alone. In this triangle ABC, we have proved that AB is equal to AC. That means ABC is an isosceles triangle because two sides are equal. So it's an isosceles triangle. Yeah. Have you, I think this exercise fully I've shared the screenshots, right?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes.
Okay. I'll let you. Yeah. Go through and I want Netra to explain proof 1 and Raja to explain proof 2. Not just reading from the slide, you will also have to answer my questions. Go through the proof. I'll just get back, children. 1 minute. Yes, Netra.
One minute, ma'am.
Raja.
Ma'am.
Yeah, proof 1 or proof 2 for you?
Proof
2,
2.
right?
Yes,
Yeah,
ma'am.
tell me. What is the
Ma'am,
information given?
the information given is that
What
ABC
kind of triangle is ABC?
isosceles triangle.
And what are the line segments BE and CF?
Ma'am,
What do you say about the line segment BE and the line segment CF?
ma'am, they both are perpendicular.
Okay, so they are perpendicular or their altitudes to B is the altitude to which side?
AC, ma'am.
And CF is the altitude to
AB, ma'am.
AB. Okay, are the altitudes equal?
Yes, ma'am.
Is BE equal to CF? Are they equal altitudes?
Yes, ma'am.
They are not equal. They are only altitudes.
Yes, ma'am. We need to prove whether they are B is
Yeah.
equal to CF.
Correct. We have to prove that they are equal altitudes. We have to prove that they are equal altitudes.
Yes,
We
ma'am.
have to prove that BE is equal to the altitude BE is equal to the altitude CF. That is,
Yes.
the sides are equal. AB is equal to AC. So when AB is equal to AC, we have to prove that the altitude on AB will be equal to the altitude on AC.
Yes,
That is
ma'am.
what the question is. ABC is an isosceles triangle with AB equal to AC. It's an isosceles triangle. So AB is equal to AC. Now we have the altitudes on the side AC and AB, on the equal sides AB and AC. We
Yes.
have to prove that in an isosceles triangle, the altitudes drawn on the equal sides are also equal. The altitudes are also equal because they're drawn on the equal sides. Okay. So is AB equal to AC?
Yes, ma'am.
Is BE equal to CF? Is it given?
It's not. We have to prove it, ma'am.
We'll have to prove that. Okay, we have to prove that. Yes. So in proof 2, which triangle has the side BE?
Ma'am, triangle 2, ma'am. That is BEC, triangle BEC or ECB.
Yeah, and which triangle has CF?
Ma'am, triangle FBC.
So you understand why we have taken up those two triangles?
Yes, ma'am. Because if
Because we have to, now we have to show BE. BE is in this triangle. BE is in this triangle. Okay,
yes,
so that's what you see here. And CF. CF is in this triangle, CF.
yes, ma'am, when we prove that this triangle is congruent to this triangle, and obviously all CF is equal to BE by CPCT.
Very good. Yeah. Now go ahead. Yes. So in the two triangles,
Ma'am, in this angle 4 is equal to angle 5. That is angle of angle F in this in triangle 1 is equal to angle E in this triangle 2, because both are ma'am.
because both are equal to 90 degrees.
Yes, ma'am.
Correct. Then
Is given.
now
After
tell me this, explain this figure, Raja. In triangle ABC, what is given in triangle ABC?
triangle ABC, line AB is equal to AC, and
So,
angle B.
so
Ma'am?
if these two sides are equal, what's the theorem? In a triangle, when two sides are equal, what is the other result you can get?
Ma'am, SA is
No. In a triangle, when two sides are equal, who can complete it?
Ma'am, opposite angles are
Angles opposite to equal sides are equal, ma'am.
Yeah, the angles opposite to equal sides are equal. Danya and Sanjay, very good. The angles opposite to equal sides are equal. So in a triangle, when these two sides are equal, the angles opposite to them are also equal. That's not given, but we get that result using the theorem. So AB, the angle opposite to AB is this angle. Opposite to AC is this angle. If these two sides are equal, then these two angles are equal.
Yes.
Why Sanjay? Why Raja? We discussed that. I already told before we started this exercise. I explained that, and
Yes.
now also some time back I was telling you. Now
You
tell me in triangle ABC, when AB is equal to AC.
The AC is equal to the opposite angles are equal.
Yeah. So you can just say this: angles opposite to equal sides are equal. Angles opposite to equal sides are equal. Okay, fine. So we have this information. Angle B is equal to angle C. Okay,
Yes,
so
ma'am.
where is angle B here? This full thing. And that will be in triangle FBC. Yeah, see here in triangle FBC, I've marked the B here equal. And this triangle, I'm sorry, this angle, where is this angle? C, this angle C fully. This angle C fully is here. And that will be in triangle EBC. This one, this one. So this is angle B. It's not this one and this one, children. It's not this one and this one. It's this one. This is only the whole of angle B. This is only the whole of angle C. See here? It's not this angle. This angle which is in BEC. BEC. Where is BEC? BEC. It's not this angle. See, that's only little of angle B. In BEC, you have angle C fully. Angle C fully. And an angle BFC, this triangle, not an angle, in this triangle BFC, you have angle B fully. Angle B. All right. Yes, so Raja, so what all we have? We have this angle is equal to this angle, and this angle is equal to this angle. And then what else we have?
Ma'am, we have that BC is equal to BC, ma'am, because it's a common side.
Okay, because both the triangles
Have
complete.
as a common side.
No, something else I want. Complete this. Because both the triangles, who can complete that? Because both the triangles
Have common base, ma'am.
have a common base. Because both the triangles have a common base, BC. You can see the main figure here. Both the triangles, they stand on the same base, BC. Both the triangles, they stand on the same base. They stand on the same base, BC. Or they have a common base, BC. So BC is equal to BC. BC is equal to BC. So what rule that is, Raja?
Ma'am, it
Two
is
angles. Two angles
and one excluded side, so it's AAS.
AAS, very good. AAS. AAS rule, the two triangles are congruent. Now, for these two angles, which is the included side?
Ma'am, FB, ma'am.
FB. And for these two angles, which is the included side?
EC, ma'am.
EC. Very good. All right. So the two triangles are congruent. And so CPCTC, we have CF is equal to BE. Very good. All right. Very good, Raja. Very good. Yes, Netra?
Yes, ma'am. ABC is an isosceles triangle and DE is perpendicular to AC. And CF is perpendicular to AB. We need to prove that BE is equal to CF.
Okay.
A is equal, ma'am, you have marked A is equal to angle 1, E is equal to angle 2, and in the triangle A is equal to angle 1, F is equal to angle 3.
Okay.
Angle 1 is equal to angle 1 because it's common.
Common angle. Angle 1 is equal to angle because it's a common angle. Yeah.
Ma'am, is equal to F and angle 2 is equal to angle 3.
Why? Why is 2 equal to 3?
It's given.
It's not given 2 is equal to 3. Why is 2 is equal to 3, children?
90 degree, ma'am.
90 degrees.
90 degrees, because each of it is equal to 90 degrees. See here, 90. This is 90, 90. Altitude, no?
Yes, ma'am, I have focused on that.
Yeah, correct. Okay. Each equal to 90 degrees. Then
ma'am, they have in the isosceles triangle they are drawn into two equal sides, AC and AB. So AB is equal to AC.
AB is equal to AC. That's given.
Yes, ma'am.
So 2 angles and
two angles.
now for these 2 angles, which is the included side? For these 2 angles, which is the included side?
Angle A.
No. For these 2 angles, which is the included side? For angle 1 and angle 2, which is the included side?
For angle 1, AE and AE and BA.
No, I'm not asking you the arms of angle 1. I'm not asking you the arms of angle 1. I'm asking you which is the side included by these 2 angles 1 and 2. Angle 1, AE.
AE, and for FA, angle 1 and angle 3.
Yeah, but we have not mentioned about AE and FA. We have written AB is equal to AC. So it will be 2 angles and some other side because we have not mentioned the included side.
We need to prove BE is equal to CF by CPCT.
Okay.
Then,
do you know how to write this order?
Yes, ma'am.
Okay, if I say BEA is congruent to
BEA, CFA.
CFA. Very good. Okay. All right, Netra. Fine. So these 2 triangles are congruent, and CPCT we have BE is equal to CF. Okay, but from the way you explained, I feel you're not very clear. Meaning you maybe you have to watch the recordings again, Netra.
Yes, ma'am.
Yeah, please, because you need to be more sure about what you're saying. You must be able to explain it more confidently.
Yes, ma'am.
Yeah, so please visit the videos and go through them. I think that will give you more confidence.
Yes, ma'am.
Yeah. All right, children, let's, this is similar to the earlier one, so I'm not explaining this. It's just a reverse of this. So here it's an isosceles triangle. Here it's given it's an isosceles triangle. It's an isosceles triangle. We have to prove that the altitudes are equal. Sorry, I'm just hurrying now. See, I just looked at the time. It's 9:50. So I'm sorry, 7:50. So I'm suddenly missing some statements. Let me do it slowly. Sorry. So here in triangle ABC, in triangle ABC, we are given that AB is equal to AC. We had to prove that the altitude on the equal sides are also equal. The altitudes drawn on the equal sides are equal. So given AB is equal to AC, we had to prove that BE is equal to CF. In the next one, the reverse is given. The converse is given. Here it's given that the altitudes are equal. The altitude CF is equal to the altitude BE. You have to prove that the triangle ABC is isosceles. That means you should prove that AB is equal to AC. Just the converse of this one, children. In 3, the triangle is an isosceles triangle with this side equal to this side. We have to prove that the altitude on this side is equal to the altitude on this side. Because they're the altitudes on the equal sides, you will have to prove that the altitudes are also equal. The altitudes drawn on the equal sides are also equal. So if two altitudes are equal, the respective sides, the altitudes, they fall on some side, right? Those two sides are also equal. If the sides are equal, the altitudes are equal. So here the sides are equal. We have to prove that the altitudes are equal. Here the altitudes are equal. See here, BE and CF to the sides AC and AB are equal. These BE is equal to CF. The altitudes BE and CF, they are equal. You will have to show that ABC is an isosceles triangle. I hope I'm clear. Here we are given that the altitude BE is equal to the altitude CF. We have to prove that AB is equal to AC. Got it, children?
Yes, ma'am.
Yes.
Yeah. Just the reverse situation. In the same way, we take up the two triangles, children. See here. Okay. You can do it either ways. This is also the proof for question number 4 in, I've just mentioned, you can understand this. Page 126, question number 4, this is the proof. This proof 1 and proof 2 are for question number 4. You can also use proof 2. You can also use proof 2 for question number 4 on page 126. Okay, so maybe you will not be able to prove that directly AB is equal to AC. Even if you can prove that this angle is equal to this angle, you can use the property. When two angles are equal, the sides opposite them are equal. So like that also you can prove. To prove that AB is equal to AC, you need not directly prove that AB is equal to AC. To prove that AB is equal to AC, you need not directly show that AB is equal to AC. Supposing you get this information, angle B is equal to angle C. That also is enough. If you prove that angle B is equal to angle C, then the sides of, when two angles are equal, the sides opposite of them are also equal. That way also you can get AB is equal to AC. You may directly get AB is equal to AC, or you can also get it through these two angles being equal. If this angle is equal to this angle, then this side is equal to this side. Here, I think by mistake I've marked, I should correct this, children. By mistake I've marked AB is not equal to AC. BE is equal to CF. See here, I've written BE is equal to CF. By mistake I've marked those two sides as equal. Sorry. Children, please correct this in your book. See, it's like this. I've by mistake marked AB is equal to AC. This is wrong. AB is not equal to AC. BE is equal to CF.
Completed.
Yeah. So I'm not really explaining this. You can help yourself. So here it is RHS, RHS, right angle, and opposite of the right angle, this is the hypotenuse. Opposite of the right angle, this is the hypotenuse. And we know that CF is equal to BE. CF, I should have marked that also, not marked. This side is equal to this side. I think I've made a lot of mistakes here, children. Sorry, I don't know. This angle is not equal to this angle. This one and this one I should remove. These two are not given to be equal, children. These two are not given to be equal. I should mark this side is equal to this side. Altitudes are equal. V is equal to CF. Here also, please make these changes. Children, these two angles are not equal. By mistake, mark these two angles. These two angles are not equal. BC is the common base. You can see BC is the common base. So equal. And then the altitude CF is equal to the altitude BE. BC is the common base. CF is equal to BE and then 90 degrees. So right angle. Angle 4, right angle. Hypotenuse. BC is the hypotenuse. Opposite of the right angle is the hypotenuse. Opposite of the right angle is the hypotenuse. And some other side. RHS is what? RHS is what? Right angle, hypotenuse, and some of the any side. Any side. So here, what do we have? What do we have here? Right angle, right angle. Opposite of the right angle is the hypotenuse. So right angle, hypotenuse, and some other side. Right angle, hypotenuse, and some other side. So RHS rule, the two triangles are congruent. So from that you get these two angles are equal. That means these two angles are equal in triangle ABC. So the sides are equal because sides opposite to equal angles are equal. All right, children, make these changes in the diagrams. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. We'll wind up with this one. Okay, so here in this figure, ABC is an isosceles triangle and DBC is also an isosceles triangle. The triangle above and below both are isosceles triangles. In the triangle above, this side is equal to this side. In the triangle below, these two sides are equal. These two sides are equal. They stand on the common base BC. Whenever it's an isosceles triangle, when they say common same base, that base will not be any of the equal sides. See, a triangle has three sides. Whenever they use the term base for an isosceles triangle, that is not any one of the equal sides. Now you may have this question in your mind that how do we know that these two sides are equal? It's marked as one thing. It's marked in the figure given to you in the textbook as one thing. But when they use the word base, that is not any of the equal sides. So BC is the common base. If BC is the common base, the remaining two sides are equal. This side is equal to this side and this side is equal to this side. So we have to prove that angle ABD, this full angle, is equal to this full angle, ACD. This angle, this full angle, ABD is equal to ACD. So one way is, children, please understand that in the triangle above, because it's isosceles, this angle 1 is equal to angle 2. And below, again, because angles opposite to equal sides are equal. Then in the triangle below, it's again isosceles. So this angle 3 is equal to this angle 4. Okay. In the triangle below, see, for this side, this is the angle opposite to it. And for this side, this is the angle opposite to it. For this side, this is the angle opposite. For this side, this is the angle opposite. So angle 1 is equal to angle 2. Angle 3 is equal to angle 4. So when you add these two, results, these two angles are equal, these two angles are equal. When you add these two results, you will get angle 1 plus angle 3 is equal to angle 2 plus angle 4. 1 plus 3 is equal to 2 plus 4. What is 1 plus 3? ABD. What is 2 plus 4? ACD. See here. ABD. 1 plus 3 is ABD and 2 plus 4 is ACD. So one way to show that ABD is equal to ACD is by using the theorem that angles opposite to equal sides are equal. So you will get 1 is equal to 2, 1 is equal to 2, 3 is equal to 4, and adding the two results, you can show that ABD is equal to ACD. The other way to show that these two triangles are these two angles are equal is by taking a diagram like this. Remove this line segment and join AD. Because why are we doing this? Because this angle is in this triangle. See, this angle is in this triangle. This angle is in this triangle. So remove that line segment BC and take the triangle like this. We have to prove that this angle is equal to this angle. So this angle is clearly in this triangle. This angle is clearly in this triangle. So we're just removing this line segment BC and we join AD. That's a construction. Join AD. That's a construction. Now you can show that these two triangles are congruent to each other. Once they're congruent, CPCT, this angle is equal to this angle. When two triangles are congruent, their corresponding angles are equal. So in these two triangles, AB of this triangle is equal to AC of this triangle. It's given. BD of this triangle is equal to CD of this triangle. Again, isosceles, both are isosceles triangles. So BD is equal to CD. And then AD is the common side. AD is the common side. So by SSS congruence rule, the two triangles are congruent. The two triangles are congruent by SSS congruence rule. And you can see here, B and C. Angle B is equal to angle C. Angle B. In triangle ABD, this is angle B. In triangle ACD, this is angle C. So angle B is equal to angle C. That means angle ABD is equal to ACD. CPCT. CPCT. So you can either show the triangles are congruent and by CPCT, these two angles are equal, or you can use the isosceles triangle property. That is, in a triangle, when two sides are equal, the angles opposite to them are also equal. You can use that property and also prove. All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you.
ma'am.
Thank you, children. Thank you.